So as we talk about how to analyze the information in the periodic table, we need to review the subatomic particles that are found in the atom. From middle school science, if you recall, protons are positively charged particles in the atom. And we can remember the charge of the proton by thinking about proton starts with P and positive starts with P. Neutrons are neutral particles, so they give no charge to the atom. And neutral and neutrons sound very similar. So that's an easy way to remember that neutrons are neutral. What neutrons do provide for the atom is another source of mass in addition to the protons. Electrons have a negative charge and they have relatively insignificant mass. So those are the three subatomic particles. This rough sketch shows us the location of the subatomic particles in the atom. So in the center or nucleus, you have the protons and the neutrons, and then you have the electrons moving around the nucleus. When we talk about defining an element, electrons are not a good choice to use because the electrons can be lost more easily than the protons and the neutrons since they're moving quickly around the center of the atom. They're on the outside of the atom. A given element can have atoms with different numbers of neutrons. So neutrons are also not a good choice for using in terms of defining an element because you could have different numbers of neutrons for the same element. Protons, on the other hand, there's always the same number of protons for the atoms of an element. So we define that an element is defined by its number of protons. That is such an important piece of information that I am going to write that down as a separate note. An element is defined by its number of protons. Thus, the atomic number, the number of protons, or the atomic number, is equal to the number of protons. So if we look at our periodic table, and let's pick group 13. We look at boron. The number of protons for an atom of boron is 5. The number of protons for an atom of aluminum is 13. The number of protons in an atom of gallium is 31. The number of protons in an atom of indium is 49. The number of protons in an atom of thallium is 81.